What's going on, everyone? Welcome back. Patrick here, moving on to another trig limit. This one, as you could tell, very similar to the previous one, where we're going to have to do factoring. So we got the limit as x approaches 3 of sine of 4x minus 12 over x squared plus x minus 12. Notice we can't do a direct substitution because we're going to have a 0 in the denominator. We're also going to have a 0 in the numerator. So if you didn't watch the previous example with factoring, highly recommend you watch that first because it's actually a little bit more simple than this one. In the previous example, we just did a change of variable once. In this example, we're actually going to have to do a change of variable twice. So it's going to be a little bit more complex, but still not too bad. So what you got to do here is you got to factor both this expression and then this expression. Notice in the previous example, we weren't factoring the expression inside the sign, but this time we do. We got to take out a 4. And we'd be left with an x minus 3 there. And this is going to be all over. If we factor this, we would end up with x minus 3 times x plus 4, like that. So now notice that we have that same factor here, like we did before, but there's this 4 here. So it's going to make things a little bit more complex, but it's still not going to be too bad. So let's just work it in steps. What I'm going to do is I'm going to split this up into two expressions. So I'm going to put the sine 4x minus 3 all over x minus 3, like that. And then this x plus 4, that's in the denominator, I'm going to put as its separate expression. So I'm going to put 1 over that x plus 4. All right, so just took this, split it up into two separate expressions, and then using limit laws, we can split this whole limit up into two separate limits that will be multiplying by each other. So I'll have the limit as x approaches 3 of sine 4 bracket x minus 3 all over x minus 3, like that. And then we'll have the limit as x approaches 3 of 1 over x plus 4, like that. Now notice that this limit, it's a little more complex than this one. Notice that this one we can just actually do a direct substitution. It's going to end up equaling 1 over 7, but we'll come back to that. Let's take this limit and rewrite it up here and try to work with it. So yeah, we'll get the limit as x approaches 3 of sine of 4x minus 3 over x minus 3. Now, I mentioned that here we're going to have to do the change of variable twice. I actually just realized while I was doing this, you can do the change of variable once if you do want to do that, and I'll show you how. But I feel like doing it twice is going to be a little more simple to see, but I'll show you both ways. So as we did in the previous example, notice that we have the same factor in both of these. And so what we can do is we could actually let theta, bring in a new variable, equal that factor, x minus 3. Split this off here. And notice how as x approaches 3, here, theta is going to approach 0. Because we're going to have 3 minus 3. So that theta is going to approach 0. And so notice that if we do all the substitutions, we'll end up with the limit as theta approaches 0 of sine of 4 theta over theta. Now from here, notice that we can't use this primary limit property yet because notice that this expression and this expression are different. Now we can use this result here where the m is this 4 and then the n is like a 1. So we do know like from this that we're going to end up equaling 4 over 1 here, which is just going to be 4. Okay, but if you want to show your work a little bit more to get to this fundamental trig property, what we got to do is we got to make this expression the same as this one. So what we can do is we can multiply this by 4, but we can't just randomly multiply the denominator by 4. We got to multiply the numerator by 4 as well. It's like we're multiplying it by 1. And so now notice what we'll have is this 4 in the numerator I'm going to take out. It's just a constant. We're going to have the limit as theta approaches 0 of sine 4 theta over 4 theta, like that. And now notice this expression and this expression are the same. But to get into this format, what we can do is another change of variable. So let's, I'm going to bring in, did I use a at all? No. So I'm going to bring in a capital A. You can use any variable you want, maybe another Greek letter, but I'll just use capital A. I'm going to let capital A equal 4 theta. And notice that as theta approaches 0, this A is approaching 0 as well. As this theta approaches 0, 4 times 0 is going to be 0. So A is approaching 0. So from here, we got the 4. And then doing the change of variable on everything here, we're going to have the limit as A approaches 0 of sine A over A. And now notice that it's the exact same format as this. Instead of the theta, we have an A now, though. Doesn't matter. It's just a variable. Ends up equaling 1. Okay, so this whole entire limit just ends up equaling 4, right? Which is this bracket. It's going to be 4. And then, like I said, we could do a direct substitution here. So we'll have 1 over 7, right? 3 plus 4. And then multiplying these, we would end up with 4 over 7. So that's actually the answer to this limit. Now, I also mentioned that instead of doing a change of variable twice, you can also do it once at this step. It's a little bit more complex, but I'll show it to you anyway. So what we can do is we can actually let theta equal that entire expression. So not just the x minus 3, but the 4 bracket x minus 3, like that. And then from here, notice that as x approaches 3, theta is going to be approaching 0, because as x approaches 3, we'll have 3 minus 3, which is 0 in this bracket, and then 4 times 0 is just 0 for the theta. Okay, so if we do a change of variable here with these parameters, we would end up with the limit as theta approaches 0 of sine of theta, right? Theta is, we let it be that entire expression, 4 bracket x minus 3. What's the problem here? The problem is we have just an x minus 3 here, while over here we let theta equal 4 x minus 3. But we don't have a 4 in front, right? So we're not going to be able to substitute just a theta here. What do we have to substitute for this x minus 3? Well, if you look here, what we let theta equal to, we let theta equal 4 bracket x minus 3. So all we really have to do is just isolate for that x minus 3. And we can do that by dividing both sides by 4. And so theta over 4 equals x minus 3. Just that factor by itself. And so for this x minus 3, we would actually sub in theta over 4. Like that. Okay. And then from here, what we can do is this sine theta, pretend it's like over 1. So we'll have the limit as theta approaches 0 of sine theta over 1 divided by theta over 4. So it's like a fraction divided by another fraction. But when we're dividing by a fraction, we can just flip that fraction and we'll be multiplying by it. So dividing by theta over 4 is like the same as multiplying by 4 over theta. And then from here, notice we could take out the 4 from this whole limit. Remember, it's the limit as theta approaches 0 of all of this, right? That entire expression. Let's take out the 4, and then we could rewrite the limit. The 4 we took out, so we're just left with a sine theta up top, and then 1 times theta is just theta. And now notice that this is in that format. It's just equal to 1, so we'd end up with 4 times 1, which is equal to 4, which is exactly what we got for this limit when we did the change of variable twice. Right? So you can do it once, just you got to be careful that when you're subbing in for this, you're not just going to be subbing in a theta, you got to be subbing in the theta over 4. So then there's a little bit more manipulation to do, but you do end up getting 4 for that same limit. And then going back to this overall limit, 4 times 1 over 7 gives you that final answer of 4 over 7.